give it at the end. Okay. So over here, for generation of these electrons, we use this klystron power supply over here. Alright? Yeah? So after, why this isolator is used is because when there is lot of electrons being generated, there is some chances that it might go backward. So this is being used to make the electrons go in one particular direction. If, as you see the direction being specified there. Afterwards, it goes to an attenuator. So this is a variable attenuator. So wherein you will be able to understand how much is the number of electrons being going for the next set of the what is this microwave devices. Okay, that we can vary it using this variable attenuator. So if it is completely already this is going in one direction, so it will not go in back. Yes. Okay. Attenuator is there because how much number of electrons you want to pass through this next half of the circuit. That it is being done using this attenuator. So if it is completely up, that means all the electrons is been passing. When you can vary the electrons also, number of electrons passing by by changing the values of the attenuator. Okay. Then after this attenuator, we have something called as this round thing is nothing but a frequency meter. Okay. We will get to know what kind of frequency this oscillator is working on using this particular frequency meter. Now, what did I say you that your what's this called? The X band is on the range of 8 to 12. Okay, so see here, guys, it is starting from. It's starting from 8.2, okay, and ending up to 12.4. Getting my point? Yeah. So this is the range of X band frequency which is there, and these lines are there. No, this one, this red color lines. So this is going to tell us in what range of frequency this particular oscillator is working. Getting my point? Yes. So after this, till here, the setup is same for all the three experiments of X band frequency. Okay. After this, here lies the change in the experiment. Can you take that one? Okay, that's called as an are horizontal. Okay, see here, everything is horizontal. So you should make sure that while you are attaching all these things, everything must be in same plane. Understood? Some loose connections, that means some of your signals are being going out and you will not be able to so this particular oscillator first of all will have there will be a lot of heat generated. So make sure that first the fan is on. Okay, and do not touch this oscillator. Okay, because you are dealing with great frequency and definitely you will get shocked. Okay, so don't touch this oscillator by any chance. Now this is going to be your power supply. What are the knobs available in this power supply? Let's check. Okay, so we have this meter selection of voltage, current, Rappler voltage, because there is a Rappler you know, what's that called, slab which is available, which is going to give us the Rappler electrons being generated. So we will have to know what is the voltage value of those this particular oscillator. So we have a Rappler voltages. Then we have something called as beam voltage. Then we have something called as Rappler voltage. Then we have these two this modulation schemes which are available. One is amplitude modulation, frequency modulation, and the other one is carrier wave modulation. Okay, so here what we are going to use is an amplitude modulation. Okay, so we will use an amplitude modulation. Then we can increase or we can change the frequencies using the frequency knobs whenever you're going for a frequency modulation, and over here we can change the amplitude for the same using this amplitude knob which is available. So this is dedicated for your AM and this is dedicated for your FM. Alright, so whenever you are starting any of the X-band frequencies, okay, so make sure that your Rappler is maximum and your beam knob is minimum. This is like a mantra for all the X-band frequencies. So what you will have to do, beam should be minimum and Rappler should be maximum. Okay, this is while you are switching on this klystron power supply also, it should be the same position. When all the experiment is done and again you are going to switch it off, also you bring back to the same position and then only switch it off. Okay, we have one more knob which is called as HT. This is called as the high transmission knob. Okay, this can be either on or off. Okay, I will tell you why we are going to use this. Okay, and the modulation what we are going to use is nothing but an AM modulation, because we are dealing with the frequencies of gigahertz. Am I correct? Now you tell me, what is the range of frequency this particular oscilloscope can withstand or can show us the output? Hundred megahertz. Yeah, and we are dealing with gigahertz. Now how is it that it's going to be done? What we are going to have is a modulated signal which is going to go inside it. Modulated signals are all high frequency components. Agree or not? Yes, we are dealing with a high frequency component, and this is called as a crystal detector. So inside this crystal detector, amplitude modulation was the demodulated circuit is envelope detector, and for that we need a diode. The diode would be there inside this, and whatever you are going to get out of this particular crystal detector is going to be a low frequency demodulated signal, which is nothing but a low frequency signal, which can be seen as an output square wave onto this oscilloscope. So giga, and we are seeing it in mega. Understood? If you make it vertical, what will happen? E plane, H plane, both of it will get cancelled and you will not get any output. Okay? Now beam is minimum, Rappler is maximum. Now switch on the power supply. Okay, now guys, even though you have switched on the power supply, now you see, since I am dealing with this component, still I have not attached it, no? I should not have any radiations which is passing through it. So that is why, even though the power supply was off, there won't be any radiations which is going to be passing through it. Why? Because my HT knob is off. Okay, suppose you feel that you have done some mistake, you will have to remove it without changing any of these parameters over here. Simply you just make HT off and then you remove the components whatever is required, attach it again, and then you switch on the HT. Okay, now once your HT is on, the first step what you have to do is beam voltage you set it to 250. So while you are setting the beam voltage, make sure that your meter selection is in voltage. once you set that to 250, what you used to do is you start reducing this particular Rappler voltage. This will be your square wave, whatever you get. Okay. Now from the maximum value of Rappler, okay, I have moved it to probably I moved it to one value where you will get the maximum waveform. Okay. Now this will be your first mode of this particular oscillator. Okay, like this. After more and more you keep decreasing, it will go to 0 and get back to a highest value, next highest value. Okay, next highest value, and this would be your mode 2. Okay, then you keep decreasing it. Again, it will go to 0, and again it will go to the next highest value, which is nothing but mode 3. Okay, this is the highest value. This is nothing but mode 3. Like this, you take 4 modes, okay, of peak to peak value, whatever you are getting over here. Okay, this is the peak to peak value, whatever you are getting here. And in your, for different values of Rappler voltages, you are supposed to find out what is the power of it. Okay, power in dB. Now 20 log 10 of V square by R. Now R is 50 ohms, constant it is. Alright, yeah, and V square is peak to peak value, whatever you are getting. So that one divided by 50 volts should give you the, and log of it should give you the power values of the same. Okay, then what is this frequency? So for every mode, now we are in the third mode. Okay, now what I will do, I will just change this particular frequency and it will come back to the same waveform however it was. Okay, now that I call it as a dip in the waveform. Okay, so when I change this, okay, it has a slight dip. See here, this dip, we call it as a dip in the waveform, and whenever there is a dip and coming back to the same position, okay, that particular way you are supposed to take the operating frequency of that particular mode. So this is in the third mode, and what is going to be the operating frequency is 2 lines are there, no? In between these 2 lines there is one red line. So wherever these 2 lines and the red line is coinciding, that value you are supposed to take. So it's 9.34. 9.34 gigahertz is the operating frequency for mode 3. So like this you are supposed to do it for all the modes. Okay. Now what you will do is you will get these values. Now what's the graph you have to get? Repellor voltage versus output power. Now repellor voltage, for the first mode you will get one maximum value, for second mode you will get some maximum value, for third mode you will get one maximum value, fourth mode you will get one maximum value. Okay, that values you will get. But for corresponding repellor voltage, you must get one value where it is going to be maximum to minimum. So 2-3 values here and there you are supposed to take the intermediate values for it, so that the graph comes like this. You're understanding? You will understand that this is mode 1, this is mode 2, mode 3 by the values, because the first mode is always the highest voltage value. Understood? Yeah? From there, wherever the reduction is there and the highest amplitude value you are getting, that would be the second, third and fourth mode. But you should take intermediate frequency so that you get this curve over here also. You should get intermediate voltages so that you get the curve like this. So plus or minus 2-3 values here and plus or minus 2-3 values here you should take it. That is why these values are so many. This full thing is for mode 1. The full thing is for mode 2. This full thing is for mode 3. And his highest value is in one particular point. Then it is plus values and minus values.
For 3 modes we have.
Usually 3 modes. Why I am telling 4 modes is sometimes you might not get proper values. So in that case you can take the 4th mode as the 3rd mode and you can match it. Now the other one is repellor voltage versus frequency. So frequency also at all these modes you will get it through the dip. Remaining frequency value will be only 0.1, 0.2 difference will be there. That you will have to match it in such a manner that you will be okay. Now this is only your experiment number 1. Okay. So after this we have something called as this vernier scale. Now see here, if you keep moving this vernier scale, this is nothing but the dip in the waveform. So you are going back and you are getting back to this. So this is for the 3rd mode. We are in 3rd mode right now. Yeah. Now what is the 0th value over here? It is in 9.5. 0th value is coinciding with 9.7. Okay. So this is for one mode. Go back to another mode. You're in 2nd mode means go to the. You're in 3rd mode means go to the second mode. And again when you get the maximum waveform, again you change it. Again when there is a dip, take down the corresponding value, minus both of it, into 2 will give you the guide wavelength of the same. Lambda g, which is nothing but 2 into d1 minus d2. So d1 is the one in mode 1 and d2 is the one in mode 2. Either any two modes you can take. Okay? And this would be in, this is a centimeter scale. Converted into meters. Understood? Then you have these things, transit time, electronic tuning, range and all. This and all calculation you can do it at home. So take any 2 modes, N1 and N2, okay? Then take the corresponding peak-to-peak voltage values, okay? From here you can find out the value of small n, because you know peak-to-peak voltage values of 2 of these modes. Then from the small n you put it off over here, okay? And this F01 is nothing but the frequency of the first mode. Find out the transit time for the first mode. Okay, and then electronic tuning sensitivity is nothing but 2nd mode frequency minus 1st mode frequency divided by 2nd mode voltage divided minus 1st mode voltage. So these formulas are already given, you just have to do this and write the values over here. Okay. Understood? Huh? Okay. So this is your first unit. First experiment. After this, what you will do, while you are switching this off, okay, so you will switch off the HT because you don't want to change any of these parameters over here. So you will switch off the HT over here and then you remove this component and then you can go for the second experiment, which is nothing but, hey, this is done now, something is done. like this magic T directional coupler.
In class theory. Yeah.
Class theory it is done. Waveguides is done.
Magic T we explain.
Magic T is there. Then what we can do is we will finish magic T and directional coupler. So you finish this in 15, 20, half an hour, and then I'll teach you the magic T and this one. Okay. You know S parameters?
This parameters.
So what